Hello everyone. Let us start new chapter number 4, structure of the atom. You have learned atom and molecules in the previous chapter. From this, you have also learned about what we mean by atom. Atom is the basic material of the any compound or matter. Now, different questions arises in the scientist mind that how this atom is differ from other element atom. Second and the main question is these atoms are divisible or not. For the first time, John Dalton tried to give the answer that you have learned in previous chapter, atoms and molecules. After that, we accepted that atoms are divisible. Means atoms, if you divide, then subatomic particles are formed. So what are these subatomic particles? And these subatomic particles are formed, they arrange in which way? Here in this lesson you have to learn about this subatomic particle, their characteristic and their drawbacks. So first we start with charged particles in matter. Charged particles. Charged particles in matter. See, you know that the shape of the atom is just like this. At the center it is called nucleus. Nucleus contains proton and neutron. Many protons and many neutrons are there. Not only one proton or not only one neutron, because different element possess different number of proton and different number of neutron also. Surrounding this, which is called orbits, electrons are revolves round. Means electrons are present in different orbits. Okay. Suppose this is proton and electron. Now you know that proton, the symbol is P, and positively charged particle. Positively charged particle. Neutron, symbol is N, it is neutral, no charge is there. And electron, symbol is E, and it is negatively charged particle. Positively charged particle proton is found in nucleus. Neutral, it is also found in nucleus. And negatively charged particle electrons found in different orbits. This is the basic structure of atom or charged particles in matter. Matter is made up of atoms, and atom possesses mainly 3 charged particles. Now let us start structure of the atom. Different scientists try to give different theories. For the first time, the first theory is given by J.J. Thomson, known as Thomson model. So J.J. Thomson theory was the first one to propose the model of structure of an atom. J.J. Thomson's theory. According to J.J. Thomson, for the first time, I think here is not given in your textbook. No? Yeah. So Thomson proposed this model of an atom to be similar to that of the Christmas pudding, just like Christmas pudding. He said that atom is the positively shaped or charged pudding-like structure. Okay, and inside this pudding like structure, electrons are embedded in it. So it is just like a sphere. This is the positive sphere, and inside it, electrons, negatively charged particles are embedded in it. This is the Thomson's model. Afterwards, this model will prove wrong, but this is the first step towards the discovery of atom. Okay, structure of the atom. So Thomson proposed that an atom consists of positively charged sphere and electrons are embedded in it. So Thomson proposed that atom is a positively charged sphere and electrons are embedded, means stitches in it. Electrons are embedded in it. The second is the negative and positive charges are equal in magnitude, means number of positive charge and number of negatively charged particles. Positive and negative charges are equal in magnitude. Magnitude means value. So atom is neutral. This is the true hypothesis. This second hypothesis is true, the first one is proved wrong later. So although Thomson's model explained that atoms are electrically neutral, the result of the experiment carried out by other scientists could not be explained this model. Okay, now afterward the most important, Rutherford's model of an atom. The most important one, the important discovery about atom. Okay, write out this. Now Rutherford's atom, its experiment also the important one. Conclusion is also important. Rutherford's experiment or model of an atom. See, for the first time, Ernest Rutherford, he performed the experiment of alpha scattering experiment. Okay, and on the basis of this alpha scattering experiment, he proved the amazing thing about atom that you know today. See, the experiment is what? So, he took a gold foil. Here in this textbook it is given that a thin gold foil, okay, and this gold foil was about 1000 atoms thick, having a mass 4.2 unit only. So see, first time he took a gold foil, very thin gold foil. Suppose this is the layer of the thin gold foil. In this foil, you know that atoms are there. You also learned that atom has nucleus. See, it has small nucleus. Okay. Now, foil is kept in front of the screen, or it is also called photographic plate. See, suppose this is the photographic plate. Thin gold foil. From this side, alpha particles are bombarded. Alpha particles are positively charged particles. Beta particles are negatively charged particles. And gamma particles are neutral. Okay, alpha, beta and gamma particles or rays, they are also known as, which was invented by Madame Curie. Not given in your textbook. So, when alpha particles are bombarded, pass over this thin gold foil having mass only 2 unit. Mass is 2 unit. These alpha particles directly pass through this gold foil and blink on this photographic plate one by one. Okay? When it blinks, then Rutherford count this blink. Then one rays pass, there is a one blink. It means what? One ray easily pass through this gold foil and make a blink on this photographic plate. Same way, he passed on 12,000 rays. 12,000 alpha rays pass through it. Out of this 12,000 alpha rays, he found that only one ray can rebound. It means what? Suppose one ray like this, it incident on this nucleus, then it can rebound. One ray when strike on the nucleus, then it can rebound. Why? Because nucleus contains some positive particles. Alpha particles are also positive. Positive and positive repel with each other, and so it rebounds. Some rays deflect also. Suppose this ray when nearby passing through not exactly incident on the nucleus, but when it passes slightly nearby through the nucleus, then it change the direction and blink here. When it deflects or change the direction, it means what? Repulsion takes place. From this experiment, Rutherford concludes that the atoms are hollow. Nucleus is at the center and nucleus contains positively charged particle. He named after it that it is a proton. So he found that because of this alpha particles, he found that nucleus contains positively charged particle at the center. Though diameter of the nucleus is very less than that of the diameter of the atom, because atom seems to be hollow. 12,000 rays easily pass. Out of this 12,000 rays, only one ray would rebound. Okay? It means the conclusion is what? See. First we write observations. This is the observation, but in a particular manner. Theory is what? Rutherford took a gold foil of mass 2 unit, very thin gold foil. He placed a photographic plate behind it, and on the other side he passed on alpha particles. Okay, then what are the observations? So most of the fast moving alpha particles, observations are what? Most of the fast moving alpha particles passed through the foil. Okay, most of the alpha particles pass through the foil. Some of alpha particles were deflected by small angle. Some of the alpha particles were deflected by the small angles. Very small angle, less deflection is there, right? And one out of every 12,000 particles, one out of every 12,000 particles would rebound. Okay, so this is the observation appear to be rebound. Now, conclusion from the observation. Write on this. Afterward, we start conclusion. From this observation, what are the conclusion? Conclusion is what? That most of the space inside the atom is empty. Most of the space inside the atom is empty. Reason is what? Fast moving alpha particle pass through the foil continuously. Okay, you can say that because most of the alpha particle pass through the gold foil without getting deflected. So few particles were deflected from that path. It indicating what? Positive charge of the atom occupies very little space. So very few particles were deflected. That is, at the center of the atom, positively charged particle is there. Particle occupy very less space. Very small space is there. With nucleus, you can say that the diameter, radius or diameter of the nucleus is round about 10⁵ times less than the radius of the atom. Radius of the nucleus is almost or about 10⁵ times less than the radius of the atom. From this also we can conclude that atom is hollow. Mainly it contains nucleus very small, just like this. Nucleus contains proton and electron revolves around it. So atom is hollow. At the center there is nucleus. Okay, and electron revolves around the nucleus. So these are the conclusion of this experiment. From this experiment, Rutherford derived what? Conclusion that is okay, but from this experiment, he said that if the mass of the gold foil is doubled, not 2 unit but 4 unit, if mass of the gold foil is doubled, or if you fold the gold foil, then out of the 12,000 rays, 2 rays cannot pass, I mean 2 rays can rebound. So he performed this experiment and he concluded that is features of Rutherford's experiment. So the features are, there is positively charged center in an atom, positively charged particles called proton at the center of the nucleus, center of the atom, that is nucleus, which nucleus contain proton. Electrons revolves around the orbit. Means Rutherford invented proton and electron, okay, and the size of the nucleus is very small. Size of the nucleus is very small in comparison of atom, in comparison of the size of the atom. Okay, see in your textbook on the page number 48, it is given that most 3 points are given that most of the fast moving alpha particles pass straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles, and surprisingly 1 out of every 12,000 particles appear to be rebound. So in the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. Now, on the basis of his experiment, Rutherford put forward the nuclear model of an atom in these features. The features I have already written down. Now, what are the drawbacks of Rutherford's model of atom? Drawback is also very interesting. What are the drawbacks? Rutherford said that revolution of the electron in a circular orbit is not expected to be stable. See, I explain you. Revolution of electron particles, revolution of the electron in an orbit is not stable. Rutherford said like this. Actually, it is wrong. It is stable. See, Rutherford said what? This is the nucleus. Okay, proton and neutron and electron revolves. So he said that when electron revolves in a circular manner, then slowly, gradually, it moves away from the orbit because it radiates energy continuously. Rutherford said that when electron revolves in the orbit continuously, then it produces acceleration. Because of this acceleration, electron radiate energy. Okay, if electron radiate energy, means loses the energy, then afterwards, after a certain cell, it moves away from the nucleus. That's why we say that number of proton and number of electrons are not same in the atom. Okay, and atom is not stable. Actually, this is the drawback. This was the wrong thing, right? So drawback is what revolution. Rutherford said that Rutherford said, revolution of the electron in an orbit is not stable. Okay, and the electron accelerate in the orbit and loses energy. That is, it radiates energy. And so atom is not stable. But you know that another scientist proved that, but afterwards it is proved that atom is stable, electrically stable, because number of proton and number of neutron are same. Proton and electron, positively charged particle and negatively charged particles are same in number. That's why atom electrically we say that it is neutral, okay, and stable. So this is the wrong hypothesis of Rutherford. So we say that it is the drawback of Rutherford. Now after Rutherford's experiment, Niels Bohr's model of an atom. This is the latest model of an atom. Let us start about Niels Bohr.